an AI project. And was that an answer you said? Yes. Okay, swag. Do you do the group project? Not yet. I can like submit it. So once you do it, just like format it, PDF, send it to me.
As a PDF?
Yeah.
Do you have a Mercury now?
Yes. I think on Blackboard, it's like there's like a tab at the top for groups that you can go.
Oh.
Or literally when the film notes on there, it has tools.
Okay.
Oh wait.
Okay.
I looked at it, I signed up, looked at this morning.
I'll send it over either. I'm probably gonna like try to submit it by Sunday.
That's fine. I'll
Like Sunday night.
I'm gonna do it by Saturday, hopefully. Good. I do it later. I will.
For the past few weeks, we've been looking at limits. We never actually said what a limit is. This is the formal definition of a limit. It's an epsilon delta definition. For right, limit as x approaches a of f of x equals L if for every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus a, less than delta, then the absolute value of f of x minus L is less than epsilon. In plain English, this says we can make f of x arbitrarily close to L, as close to L as we want, by choosing x to be sufficiently close to A. We're going to include this in here as well, the strategy for doing a proof. Generally speaking, there's no one right way to do a proof. Now we'll start with let epsilon be greater than 0. Then you want to find a value for delta. And that's going to go through all this. Yeah, I never do it this way. That's there for your needs. Something that we will be using a lot is the triangle inequality, which you should be familiar with. Just simply says for all real numbers a and b, the absolute value of the sum of the numbers is less than or equal to the sum of the absolute values. Then we can define the limit from the right. Notice around the x minus a, the absolute value has been removed because it's always guaranteed to be positive. Define the limit from the left, which is again the same way, but notice it's now negative delta, less than x minus a, less than 0. We just applied the fact that absolute value turns into the negative of x minus a, and then distribute the negative out. So what it means for a function to increase without bound, for every m greater than 0, there is a delta greater than 0, such that if 0 is less than the absolute value of x minus a less than delta, then f of x is greater than m. Okay, that means there's no upper bound on f. You can always find a larger value. Right, and likewise for decreasing without bound. F of x is less than negative m. Limit at infinity. This is an epsilon n definition, which is used quite a lot. Say the limit is L if for all epsilon greater than 0, there exists a capital N greater than 0, such that the absolute value of f of x minus L is less than epsilon for all x greater than n. And a similar definition at negative infinity. And they combine them to have an infinite limit at infinity. I'm not going to spend too much time on the actual definitions themselves as much as I want to just use them. Prove the limit. So here they're telling us the limit is 1, and they want us to prove it. We're being given an epsilon value. We want to show there exists a delta greater than 0 such that absolute value f of x minus L is less than epsilon whenever the absolute value of x minus 2 is less than delta. Now what we did by stating this. We want to show that there is a delta that makes that a true statement. Is allow us to quit once we find that delta. That means all that I'm going to do is show you how to find the delta. And then I'm done. Start with the absolute value of x minus 2. I'm sorry, not that, sorry. Wrong one. Absolute value. 3x minus 5 minus 1. Simplify that. So what? Absolute value of 3x minus 6. If you take the product, if you take the absolute value of a product, what can you do? Go ahead.
I think it would be the product of the absolute values.
It is. It's the product of the opposite values. What's the absolute value of 3? But absolute value of x minus 2 is less than delta. So that whole thing is less than 3 delta. Transitivity. For our desired absolute value to be less than epsilon, 3 delta has to be actually less than or equal to epsilon. A is less than B, B is less than C, that means A is less than C. We also have A less than B and B equals C. A would have to be less than C as well. Transitivity. Delta would have to be less than or equal to epsilon over 3. Choose delta to be epsilon over 3. I just showed that a delta exists. I'm done. And the proof is complete. fairly straightforward. Unfortunately, they're only that nice if it's a linear function. And they get really hairy if it's a non-polynomial. So it always starts off the same way. Let epsilon greater than 0 be given. We want to show that there is a delta such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. Start with the absolute value of x squared minus 1. Difference of squares, right? Absolute value product of the absolute values. But the absolute value of x minus 1 is less than delta. We have a problem right now. Our choice of delta needs to be independent of x. Let's add an additional restriction. Let's assume that delta is also less than 1. Sorry. Then now we're meaning the absolute value of x minus 1 would have to be less than 1. I'm actually going to make that less than or equal to 1 to make the logic better. It doesn't really matter. Nothing changes. Another way of writing that. Are equivalent, but so you're gonna have to again think back to when you studied absolute values. This is an algebra. Absolute value of x is less than a. What is a way of saying that without the absolute value?
Is it x is less than or equal to a? I just guessed.
There is an x less than a. I agree with that.
I feel like the square root of the square one of those.
Mm-mm. You make your algebra teachers very sad. Negative a less than x less than a. They're the same thing. I didn't want to new slide. That would mean that x is between 0 and 2. X plus 1 would be between 1 and 3, right? But wait a minute. If x plus 1 is larger than 1, is x plus 1 larger than negative 3? Which allows me to say the absolute value of x plus 1 is less than 3. So we already had that, right? Absolute value of x squared minus 1 was less than delta times x plus 1, which is now less than 3 delta. Three delta would have to be less than or equal to epsilon. However, we added an additional restriction in here. We said delta was going to be less than or equal to 1. So we take delta to be the minimum between 1 and epsilon over 3. Remember, epsilon can be anything as long as it's positive.
Oh, this one.
Start with the absolute value of the square root of x minus square root of 2. Just rationalized it, right? You can split the absolute value across division as well, because division is just multiplication. Absolute value of x minus 2 is less than delta, so this is where we're at right now. And proceed in much the same way as we did before. Time to reset. Away. We now suppose that delta is less than or equal to 1. Then the absolute value of x minus 2 would have to be less than 1. X minus 2 is between minus 1 and 1. And so x would be between 1 and 3. So this is where we're at right now. One plus root two is positive. Yeah, this is where we're at. This is now where we're at. We have less than delta over root 3 plus root 2. So delta is the minimum between 1. And just remember, all this work was done with the assumption that delta is less than or equal to 1. Or the quantity of root 3 plus root 2 times epsilon. Delta exists, so we're done. Absolute value of x. Absolute value of x minus 0 is just absolute value of x, right? What's the absolute value of the absolute value of x?
X. Negative X.
The absolute value of x.
Just the absolute value of x.
And what if that just be X though?
What if x is negative 2?
Okay.
But since the absolute value is already positive, that extra absolute value is redundant. Oh, look. That has to be less than delta. Absolute value of x minus 0 is less than delta. So in this case, we just have to take delta to the epsilon, we're done. Easy. Look at this one. Limit is x approaches 0, sine of 1 over x. We examined that and concluded it didn't exist. Now we get to explain why. Let's take epsilon to be a half. Any delta greater than 0. You can easily find two values, x1 and x2, satisfying those two absolute values. And having that absolute value be greater than or equal to 1. In fact, I can choose an x1 and x2 such that that difference is 2. That's greater than epsilon. And notice that we can do that for any value of delta because of the oscillatory nature of sine. That's all I needed. Right. Your sine of x, what this is saying, the sine of 1 over x is never restricting into a band. No matter how close I choose an x.
So it would be negative instead of positive.
approaching from your side.
It's going to oscillate between -1 and +1, but there's no value where sine is always within an epsilon band. Right, and that band's shrinking. Because that's the whole point of a limit. You can shrink that band, and it will always still be within that band for certain values of x. That's what this is saying. I can't do it. I can't restrict it.
Oh boy. These types of proofs I did a lot. Good old real analysis. Do I have any math pages in here? Then you don't have to worry about real analysis. Unless you're a masochist and you want to take it.
Still start with assuming that epsilon greater than 0 is already given to you. Notice that we're now going to infinity. What we now want to show is that we can find an n larger than 0 such that got to do the -2. That's not good. Need you. Such that the absolute value of f of x minus L is less than epsilon for all x greater than that n value. Right, so you're picking a point on the x-axis such that your function of 2 plus 1 over x is within epsilon of 2 to the right. And that slides. So it keeps shrinking. Right? No matter how small I decide to make that epsilon band, I can find a point such that f of x is with, or the 2 plus 1 over x is within that band everywhere to the right of it. Well, isn't that just the absolute value of 1 over x? Which is what? 1 over the absolute value of x? Has to be less than 1 over n. Okay. Because n is positive, and so is the absolute value of x. I can actually just drop the absolute value of x, to be honest, and just make it x because we are approaching infinity for x, which means x is positive. So don't we just choose n to be 1 over epsilon? You can work backwards. If you choose that, you get 1 over epsilon, which is just epsilon, in for there. And then that's got to be greater than 1 over x, so on and so forth. These are generally better to prove than limits out of point. Absolute value of f of x minus L less than epsilon for all x greater than n. Can't you write 5x plus 1 over 2x as 5 halves plus 1 over 2x? Just 1 over 2x, right? I can drop the absolute values, again, because x is going to infinity. So x will be positive. But that's less than 1 over 2n. Yes. It's a fraction. X is larger than n, but because x is in the denominator, I'm back. Absolutely. Yeah, it's a relatively simple one. Get rid of the absolute values. One over root x, that's going to be less than 1 over root n. We want that to be less than or equal to epsilon. Let n be 1 over epsilon squared. Or if you don't like the fraction, epsilon minus 2 doesn't matter, same thing. Oh no, I see squareds. Maybe this won't be so bad. No, not delta. Oh, bummer. It's 1 over x squared. That doesn't seem too bad. Is that true?
It's no.
It is not. Why?
Because x is greater than it.
What's that got to do with it? If x is larger than n.
Oh,
This, is the square, is n to the negative positive? Wait, no.
No, that doesn't matter, because n guaranteed to be positive.
Yeah, because you're going positive.
So that is the equivalent of this. If x is larger than n, then x squared is larger than n squared. Those two statements are the same. Why is that statement not true? Because you're right, it's not a true statement.
Because of the less than sign?
Less than is not, those two statements are the same. Right, we know that x is greater than n, that means that 1 over x would be less than 1 over n. And I'm trying to claim that that means that 1 over x squared is less than 1 over n squared, which it's not. That's the same thing as saying x larger than n means x squared is larger than n squared, which is not true. Go ahead.
I know there's like stuff with negative numbers, but also like between 0 and 1, you square a number and you count.
If you take a value less than 1 and square, it gets smaller. Which means for values of x between 0 and 1, 1 over x squared would be larger than 1 over n squared. But if I now say for x larger than 1, I have a true statement. So I'm restricting my value for x. It must be larger than 1, which means n has to be larger than 1. Right? So take n to be the maximum between 1 and now say 1 over n squared is equal to epsilon solves for n. Be what, 1 over the root square root of epsilon? I don't feel like writing a fraction. Epsilon to the minus half. Larger of those two values. Now you know what the limit is. Glad I'm not testing you on it. Then we can get really crazy. Prove that using an epsilon delta proof. Don't even try it. It's going to be really advanced. That would be beyond the scope of the calculus course.
Is that like differential equation or linear algebra?
No, it's even beyond that scope.
I can use like Taylor series or something.
You might be able to get away with that. You probably wouldn't see something like this until a real analysis 2 plays or something. Maybe real 1, but I don't remember seeing this in my real 1 course. And again, that's still a relatively tame function. No homework on this section. So, 15 minutes left, your choice. spend it doing this worksheet, you could spend it finishing up that project, you could split your time. And maybe just work on this a little bit, just to get a firmer foundation on what a limit is, work on that fleet project, work on the AI stuff, whatever. But use the rest of the class times wisely. So if you get new groups, I'll give you the worksheet. And also, if you signed up to get the handouts, make sure to stop up and see me before you leave.